Hi, so today we're going to learn about functions. So the definition of a function is a function is a set of ordered pairs in which no two ordered pairs has the same first coordinate and different second coordinate. So basically, you cannot have the same x coordinate. So the first example is a parabola, and it is a function because they do not have have the same x value. So we have a 1, 1 and negative 1, 1. So either our x values are different. The other one is not a function because they have the same x values. Over here we have the point 1, 1 and the point 1, negative 1. They both have the same 1 value as an x because they have not a function since they have an x value more than once. So I'm just going to go over some rules and then some theorems, and then we'll start doing problems. So an independent variable is the variable that corresponding to the first coordinate they are controlled. It's something you cannot pick. In linear function, x values are independent variables since they are given and controlled. So the x values are the independent value in linear functions. And dependent variables in functions are variables corresponding to the second coordinate. Example, the y values of a linear function. So that was pretty self-explanatory. Okay, now we're gonna determine if an equation is a function by using a vertical line test. So the vertical line test theorem states that a graph is the graph of a function if and only if there is no vertical line test that crosses the graph more than once. So basically, if you put a vertical line test through through an equation, and it hits the point more than once, then it's not a function. So the first one is not a function because it hits the line more than once, right? So it's here once and then here again second time, so it's not a function. This one is a function because if you put a line through it, it only hits it once. This one as well is not a function because if you put a line through it, it hits the line more than once, so it's definitely not a function. Okay, now we're going to go over domain, range, and function notation. So domain is the set of all first coordinates of the ordered pairs. So it's basically just all the x values of a relations. So example, you're given the coordinate 4, 2 and 1, negative 3. So the domain would be just 4, 1, right? And the range is the set of all second coordinates of the ordered pairs. So it's basically just all the y values. So an example would be you got coordinate of negative 1, 0 and 10, 2. And then the y values would be so the range would be 0, 2. Because that's your x, that's your y, yes, 0, 2. And a function notation is a function defined by a set of ordered pairs that can be named with a letter. Example, this whole thing is a function notation, so you're given, so it's a set of ordered pairs named with a letter. So it's just, an example would be exactly like this. And then the rate of change is if x not 1, x1, y1 and x2, y2 are two ordered pairs of a function, we define the average rate of change of the function as x varies from x1 to x2 as. So basically it's basically the numerator is just the change of y, and then the denominator is change of x. So it's y2 minus y1 over x2 minus x1. So now let's do some problems. So the first problem says use the vertical line test on each graph to determine whether y is a function of x. So remember the vertical line test, if it hits it more than once, it's not a function. So is this a function? Nope, because it hits it more than once. Is this a function? Whoops. Nope. Is this a function? Yes. Is this a function? Yes. How about this one? Yes. And how about this one? No. Good. That was pretty easy. So this one says determine whether each relation is a function. So basically, you have to look at the x. So determining whether each relation is a function. So basically a function means that you cannot have the same x values more than once. So let's look at their x values. We have a -1, 1, -5, and 5. Are any of these the same? No. So they all have different x values. So yes, this is a function. This is definitely a function. Okay, so let's do another one. So determine whether each equation defines y as a function of x. So for this one, I'm not even good at plot points. What I'm gonna, well, you could plot points, so, but you can also graph it, and if you don't know how to graph it, you can put it in a graphic calculator. Okay, so we know that vertical line tests, vertical graphs looks something like this, right? The only difference is it's x equal y, so it's going to be like flipped. And I put this in a graphing calculator, so it should look something like this. And then if you use the point 10, you get a y value of 5. And you also get a -5 right here. So this is 10 comma -5, and then this is 10 comma 5. So notice that it has the same x values, 10 and 10, right? So it's not a function, and also if you put a vertical line test, it fails. So no, not a function, since they have two same x values. Two same x values. Okay. Determine the domain and range of each relation. So you're given x equals negative y squared. So if you don't know what that looks like, it looks kind of like a parabola, but flipped. So it will look something like this. So it looks something like this. So I don't even want to use plot points. I'm just going to use the vertical line test. It hits it more than once, so no, it's definitely not. It's not a function. Oh wait, it's not a function definitely, but they want to know the domain and range. So just So we're going to find the domain and range. So remember, domain is all the x values. So here's the x-axis, and the range is all the y values. So it's this graph is possible in quadrant 2 and quadrant 3, right? So let's look at the x values. So our domain. Okay, so it's not in quadrant 1 or quadrant 4, because so we can't say, so the domain is definitely not going to be positive. But okay, so we're going to say it's definitely going negative, but as this continues, right, continues, as x becomes more negative, y becomes more positive, right? So our domain is the x values. You have to, so I'm going to say it's from negative infinity, and then it stops right here, right? 0. That's what our domain is, because if it keeps going, as x becomes more negative, y becomes more positive and negative, right? But it stops right here at the x value. So think of it as like the limit. What is the limit? So the domain is, and I'm going to use bracket 0, because when you plug in 0 for x, right, you still get 0, y equals 0. So that's why 0 is included. Now let's look at the range. Remember, the range is all the y values, so as x becomes, we have to look at this side and then this side. Remember, it's the limit. So as x increases, x becomes more negative, y becomes more positive, right? It'll keep on going like this. It'll keep on going. So y will become positive, right? And then as x increases, what happens here? The y becomes more negative, right? It'll go like -5, -6, -7, etc., right? So what would our range? Our range would be from negative infinity to positive infinity, or you could call this all real numbers, right? Think of it as a limit. So as x increases, what happens to the y values for the positive side? It increases. As x decreases, what happens to the y values on the negative side? Here's the negatives, right? It decreases. So that's why we have from negative infinity to positive infinity, or all real numbers. Okay, so we have the relation, not really, we have the function notation of f equals 2, 6, 3, 8, 4, 5, and then we have the function g of x equals 3x plus 5. So we could find f of 4 and g of 4. So let's look at the f of 4. Remember, so this is the xy, y value, xy, x, and y. And then this is this f is called the function notation. So basically, when you plug in f of 4 into this function, you're going to get a y value of 5. So that's how you read it. Here's 4. Your y value, if you plug in f of 4 into this function, you're going to get a y value of 5. So that's how you read it. So f of 4 equals 5. Now, let's find g of 4. What is g of 4? So we have the function g of x equals 3x plus 5. So you just have to put in 4 into the function. So wherever you see an x, you plug in 4. So it's 3 times 4 plus 5, which is 12 plus 5, which is 17. So 5 plus 17 is 22. that's your final answer. So let's say we're given the function, given f of x equals 3x squared minus x and g of x equals 4x minus 2. So we got to find this. What is f of x plus h minus f of x? So let's look at the function f. This is our function. So we got to plug in x plus h into that function. So what is x plus h? So wherever there's an x, you plug in x plus h. So it's going to be 3, and then that would be x plus h square minus x, which is x plus h, right? You could think of x plus h as an x. Okay, so let's simplify. So this I know it says 3, and this is going to be x squared plus 2xh plus h squared minus x plus h. So if you distribute this 3, it's going to be 3x squared plus 6xh plus h squared, and then I'm going to distribute this negative. So this is going to be negative x minus h. Let's see if anything cancels. Let's see. The h, whoops, no, nothing cancels yet. So don't cancel anything right now. So f of x plus h is this thing. 3x squared plus 6xh plus h squared minus x minus h. Now we're going to subtract this from negative f of x. So minus f of x is this whole thing. So it's going to be 3x squared minus x. So I'm going to distribute this negative, so this is going to be negative. This is going to be negative 3x squared plus x. And then bring down whatever you have left. So this is just 3x squared plus 6xh plus h squared minus x minus h. Now we can check if anything cancels. So the x cancels, right? The 3x squared cancels. And then wait, I'm missing. Yeah, that's it. So you should be left with 6xh plus h squared oh darn, right here I made a mistake. So it should be 3x squared plus 6x plus 3h squared. So this should be plus 3h squared. So your final answer should be 6xh plus 3h squared, and then minus h. So if you make one mistake, the whole thing is wrong. So yep, that's your final answer for that one. So now let's do a word problem. So it says, if a new Mustang is valued at 16,000 and 5 years later it is valued at 400, then what is the average rate of change of its value during those 5 years? So they're given, here's the age, years, and then here's the value, thousands and thousands of dollars. So we're given 2 points, 0, 16 and 5, 4. Yeah, 5 comma 4. So they want to find, it's basically, so the rate of change is the same thing as slope. So rate of change is y2 minus y1 over x2 minus x1, right? And we're given 2 points, 0, 16, 5, 4. So what we can do is label this x1, y1, x2, y2. So we just got to put it in this formula. So y2 is 4. Oh, and don't forget, this is thousands. So this should be 4,000, 1, 2, 3, and then this should be 1, 2, 3, 16,000, right? Because it's in thousands of dollars. So 4,000 minus 16,000. Whoops, because y2 is 4,000 and y1 is 16,000. That's how I got 4,000 minus 16,000. And then x2 is 5 and x1 is 0. So if you did the math, you would get, we could call this m as well, negative 12,000 over 5, and then that should give us negative 24,000 per year. I mean 2,400 per year. So yeah, that makes sense, because like, just looking at this, it's definitely, the slope is definitely negative, right? Because it's going this way. So so the rate of change in value is negative 2,400 per year. Okay, the last one, and this one's always the longest. So it says find the difference quotient for each function and simplify it. So we're given g of x equals 3 over x plus 2. So let me write, what is the difference quotient? So the difference quotient is this formula, f x plus h minus f of x. So this is definitely the difference quotient. So we can, g of x is the same thing as, you can also say it as f of x, right? They're both the same thing, 3 over x plus 2. So first step I'm going to do is, I gotta find, so that we're going to use this formula, right? So I gotta find f of x plus h. I gotta find this. Here's the function f, so wherever we're going to plug in x plus h. So wherever you see an x, you plug in x plus h. So this is 3 x plus h plus 2. Good. And then minus, so let me put it right here. So it should be 3 x plus h plus 2 minus f of x. So f of x is this thing. So 3 over x plus 2 all over h. Okay, so I'm going to look at the numerator. I want to simplify these two. So we got to find a common denominator of x plus h plus 2 and x plus 2. So the common denominator of those two is x plus 2 times x plus h plus 2, right? Because if there's nothing common, you multiply it by the 2. So over here we're just missing an x plus h plus 2, right? Plus h plus 2. You gotta multiply it top and bottom. And over here we are missing an x plus 2. So I'm going to multiply top and bottom by x plus 2. X plus 2. So let me distribute. So 3 times x plus 2 is 3x plus 6. Now what I'm going to do is I'm going to distribute it, and also I'm going to do the negative. So it would be negative 3 times x is negative 3x. Negative 3 times h is negative 3h. And then 3 times 2 is 6, and then the negative would be negative 6. All over x plus 2, x plus h plus 2, all over h. And then the h is over 1. So let's see. Let's look here in the numerator. Does anything cancel? We can cancel the x, the 3x, and then the 6. So you're left with negative 3h over, don't forget this denominator, so it would be x plus 2 and then x plus h plus 2. All over h, and then you can put that over 1. So what is, I'm going to do the brackets. So we have a 1 here and then x plus 2 times x plus h plus 2. What is our common denominator? It's just this, right? So I'm going to multiply both sides by x plus 2 times x plus h plus 2 plus h plus 2. So over here, if you times this by that, that cancels. So you're left with negative 3h, because this cancels if you multiply this. And then over here, h over 1 times x plus 2 times x plus h plus 2 would be h x plus 2 times x plus h plus 2. Does anything cancel? Oh yes, it does. The h. So you're left, let me put it right here. No, I'll put it right here. So you're left with negative 3 over x plus 2 times x plus h plus 2. And that's your final answer. And that wraps it up for this section.